Assalamualaikum warahmatullahi wabarakatuh and very good morning. So in this video, we are going to learn one of the continuous probability distribution, which is exponential distribution. Exponential distribution related to Poisson distribution. So let's just recall back, what is Poisson distribution? Poisson distribution is a discrete probability distribution, and it describes the number of successive events over interval of time or space. But the exponential distribution, it is a continuous probability distribution, and it describes the times between successive events in a Poisson process. Let's differentiate what is Poisson and exponential. So yes, now I said Poisson is the number of successive events in an interval. Okay, for example, here we have number of cars, okay, passing a toll gate in 2 hours. So this is interval, okay, in 2 hours. So we count how many number of cars, okay, pass a toll gate. Right? But for the exponential, we count number of hours between car arrivals. So this is our focus, number of hours between car arrivals. Okay, another example, number of students arrive at library in 1 minute. So this is a Poisson distribution because we want to know in this 1 minute, okay, how many students arrive at the library. Okay, but for the exponential, okay, we focus on number of minutes between the arrivals of the student at the library. Okay, so to conclude, Poisson, we focus on the number of events per single unit of time or space. And for exponential, the time taken per single event. Okay, so I hope that you understand the difference between Poisson and exponential. So suppose a random variable x denotes the distance between the successive events of a Poisson process with mean lambda. So lambda is the rate, okay, then or the mean. Then x is an exponential random variable with parameter lambda, where we can write it as x follows exponential exp, given lambda is the mean. And the probability density function is given as f of x equals to lambda exponential to the power of negative lambda x. So since exponential distribution is a continuous probability distribution, so we need to integrate the function with respect to x. And after integrating, we can simplify with this, or we can come out with this formula. Okay, if you want to find the probability of the random variable less with x or any value, so you can just get the formula, which is 1 minus exponential to the power of negative lambda x. Or if you need to find the probability of x greater than x, so the solution from the integration would be exponential to the power of negative lambda x. Okay, so if you have a question, okay, and then you want to solve the integration, you can just use this formula. Or if you don't want to use this formula, you can just start, okay, from finding the probability. Let's say if x less than x, so meaning that you have to find from a certain value. For example, you have to find x less than 3. Okay, so meaning that you have to find from negative infinity up to 3. And the formula given just now is lambda e to the power of negative lambda x dx. Okay, so at the end, okay, once you solve this, the solution is in terms of 1 minus e to the power of negative lambda x. Okay, but if you need to find x greater than 3, so you have to find from 3 up to infinity of lambda e to the power of negative lambda x dx, given x is our 3. Okay, so this one is our 3. So once you solve this, you will get, okay, the solution for this integration is in terms of e to the power of negative lambda x. So the mean and the variance for the exponential distribution with parameter lambda is given as the mean is equals to 1 over lambda and the variance is equals to 1 over lambda square. Okay, so this is the mean and variance for the exponential distribution. Now let's try this example 3.13, question 1. So in a large corporate computer network, user log-ons to the system can be modeled as a Poisson process with a mean of 25 log-ons per hour. So we want to know what is the probability that there are no log-ons in an interval of 6 minutes. Okay, so this is our concern. Okay, we want to know the probability that there are no log-ons in an interval of 6 minutes. So how to solve this? So first, let's define what is our x. So x represents the time in hours from the start of the interval until the first log-on. Okay, so our focus is to know the time in hours. Okay, the time in hours from the start of the interval until the first log-on. Okay, so here we want to know the probability that there are no log-ons in an interval of 6 minutes. So within these 6 minutes, okay, there are no log-ons. Okay, so now, meaning that our focus is that we want to find, okay, either after 6 minutes, okay, we have to check after 6 minutes, is this 6 minutes has any log-ons. Okay, so our x would be greater than 6 minutes, but our x is in hours, so we have to change 6 minutes into hours. So how many hours equals to 6 minutes? So 1 hour is given as 60 minutes. So to find 6 minutes, meaning that it will be x equals to 6 over 60 minutes. Okay, so here is equals to 0.1 per minute. So x is greater than 0.1. Okay, and another thing is that we have this mean, which is equals to 25 log-ons per hour. Okay, so that is our lambda. Okay, so now to solve this, first there are two methods. Okay, the first one I'm going to show you the manual method. Well, remember, since it is exponential problem, because x follows exponential, given lambda is 25. Okay, so this can be solved using the integration. So x greater than 0.1 would be from 0.1 up until infinity, and the function would be lambda, okay, times with exponential to the power of negative lambda, where lambda is given as 25x dx. Okay, now we can solve this integration. 25 exponential to the power of negative 25x. Then you have to differentiate the power here, where you will get negative 25. So the interval from 0.1 up to infinity. Okay, so simplify this, you will get negative of e to the power of negative 25x given from infinity up to 0.1. Okay, so e to the power of negative infinity would be 0. Okay, minus with negative of e to the power of negative 25. X is given as 0.1. Okay, and you will get e to the power of negative 25 times with 0.1, which is e to the power of negative 25, 2.5. Okay, so this is the answer. So if you notice, okay, so these are the steps, okay, where we have to solve this. So if you still remember the previous slide that I show you, okay, given if probability of x greater than x, where the answer would be e to the power of negative lambda x. So here you can see that this is our lambda and this is our x. So the previous slide show you the solution after the integration happened. So in the test or exam, if you want to solve this problem, okay, you can use the integration to solve this, or if you remember, you can just straight away use this, okay, to obtain the probability of x greater than 0.1, which is equals to e to the power of negative lambda times with x, which is 0.1, and you will get the same answer as in this integration. Okay, so you can give this answer like this, or you can give the value for this exponential negative 2.5, which is equals to 0.082. Let's try another example. Okay, a checkout counter at the supermarket completes the process according to an exponential distribution. So it's already stated that this problem is an exponential distribution. Okay, with a service rate of 6 per hour. So meaning that this is our lambda. Okay, so now a customer arrived at the checkout counter. Find the probability of the following events. So here, let's define our x. So x will be time in hour, time in minutes. Okay, this one because all of it in minutes, so it's easier for us to use minutes. Time in minutes for a customer arrive. Okay, arrive at the counter. Arrive at the counter until leave the counter. Okay, and given that 6 per hour is our lambda, so lambda is given as 6 per hour. Okay, so that is the rate. So meaning that in 1 hour, they complete 6 customer. Okay, 6 equals to 1 hour, but this x is in minutes, so we have to change this or to find this in minutes. So 6 minutes in 60 minutes. So now how many customer complete within 1 minute? So our lambda would be equals to 6 over 60 minutes, meaning that the rate is 0.1 per minute. Okay, now we have obtained all this. So let's try to find the probability for each of these problem. So we want to find the service is completed. So this is our service, the first service and the second. Okay. So this is our service. Okay, completed fewer than 5 minutes, less than 5 minutes. So we want to find the probability that this service, okay, complete in 5 minutes. So X will be less than 5 minutes. So I'm not going to show you the integration, but I just give you the solution, okay, where it will be, we will use since X is less than 5, so the solution for this will be 1 minus e to the power of negative lambda x. So you just have to substitute, okay, lambda, our lambda, which is 0.1, and our x is obtained from here, times with 5. Okay, and you will get 0.3935. Then the next one, okay, the customer leaves the checkout counter more than 10 minutes after arriving. Okay, so meaning that starting from he arrived at the counter until leave the counter, it takes him more than 10 minutes. So we want to find the probability of this, x greater than 10. Okay, so if greater than, so the solution would be e to the power of negative lambda x. So lambda would be 0.1, x is this 10. Okay, and you will get 0.3679. Okay, and the last one. So the service is completed in a time between 5 and 8 minutes. Okay, so it happens between 5, okay, and 8 minutes. So we can write it as x. X is between 5 and 8 minutes. Okay, so since it is between 5 and 8, so we can write it as the probability of x less than 8 and, okay, minus with probability of x less than 5. Okay, why x less than 5? Because, okay, here is our focus. We want to find between 5 and 8. Okay, so first we need to find for x less than 8. Okay, x less than 8, so will be this. So to get this, meaning that to get this area, meaning that we have to remove this total also. Okay, meaning that from the probability x less than 5. So at the end we will get only the time between 5 and 8. So x less than 8 is 1 minus e to the power of negative 0.1. X is 8 minus with 1 minus e to the power of negative 0.1 times with 5. And you will get 0.1572. Okay, so that's how we solve this question number 2. Let's try the last example. The number of hits on a website follows a Poisson process. Given the rate is 4 per minute. Okay, now we want to find what is the probability that more than 2 minutes go by without a hit. Okay, so we focus on the minute. Okay, minute more than minutes without a hit. Okay, so let's try this. So our x is given as, denote as the time in minute. For a hit on a website. So x follows exponential given lambda is 4 per minute. So here our x is in minute, and this one is also in minute, so we don't have to change anything. Okay, so our lambda is equals to 4 per minute. Okay, so I will write here as 4. Okay, so now for A, we want to find the probability that more than 2 minutes. Okay, given that this, okay, we have exceed 2 minutes, so x will be greater than 2, given that there is no heat, okay, more than 2 minutes. Okay, so it will be e to the power of negative lambda x, because this one is greater than. Okay, so e to the power of negative lambda is 4 and x is our 2. Okay, and you will get 3.3546 times with 10 to the power of negative 4. Next, for the next question, okay, here we have if 2 minutes have gone by without a hit. Okay, so we have waited for 2 minutes. Okay, and then what is the probability that a hit will occur in the next minute? So within this 1 minute, okay, there is a hit here. Okay, so how can we solve this? Okay, so here involve a conditional problem. Okay, so for a conditional problem, we will use this conditional probability. Okay, given that here, okay, this is our first explanation. Okay, given that we need to find the probability of x, okay, greater than, so t1 is the time for the first event, okay, plus with the time taken for the second event happened. Given that, okay, the random variable is greater than the time for the first event. Okay, so if this conditional happen, it is equals to the probability of x greater than the time taken for second event happen. Okay, and for the second condition, given that the probability of x less than, okay, the time taken for the first event plus with the time taken for the second event happen, would be given as, okay, given such that x is greater than the first event happen, the time taken for the first event. Okay, so this is equivalent to the probability of x, okay, less than the time taken for the second event. Okay, so maybe you will not understand, okay, this formula, but we can apply this into the problem, okay, into the previous problem in question 2b. Let me explain again on 3b. So if 2 minutes have gone, so we have waited for 2 minutes, these 2 minutes, and there is no hit within these 2 minutes. Okay, and then another minute in the next minute, so this one as 1 minute, in the next minute there is a hit. Okay, so remember, we have waited for a hit to happen within these 2 times, right? Okay, where these 2 minutes refers to the first event, okay, that we wait for a hit in 2 minutes, and this 1 minute is the another event, okay, we have wait for another minute after these 2 minutes, and here we have a hit. So if we want to write it, okay, in this conditional problem, conditional probability here, so remember that we have waited for 3 minutes. Given that, okay, the time to get a hit, okay, is greater than 2, because we have waited for 2 minutes, but in the next minute we have a hit. Okay, so this probability is also equivalent to finding, okay, the probability of x less than 1 minute. Okay, where this is given as T2. Because, okay, here, what is the probability that a hit will occur in the next minute? Meaning that it will be less than 1. So in general, okay, you have waited for 2 minutes, okay, without any hit. Okay, so the probability, okay, to get a hit in the next minute is just the same as the probability of getting a hit, okay, within this 1 minute. Okay, so you just have the fact that you have waited for these 2 minutes without a hit doesn't change the probability of the hit, okay, that happened in the next minute. Okay, so next we can just use this x less than 1 to find the probability that a hit occur in the next minute. Okay, so x less than 1, it will be 1 minus e to the power of negative lambda. So our lambda is given as 4 times with x is given as this one, 1. Okay, and you will get 0.9817. So that's the end of the exponential distribution. Please try the exercises that I have provided in this slide. Thank you.